The problem is not the bench press. The problem is how we understand it. Because when force is misunderstood, the body pays the price. Today we examine the bench press, not as a chest exercise, not as a technique checklist, but as a mechanical problem solved under load. A fundamental strength skill. If we get this wrong, everything that follows breaks. Before we debate grip width, angle, skews, or safety, we must answer one question. What the bench press actually is? The bench press is a loaded multi-joint pressing task. It requires coordinated force production at the shoulder and elbow while the body stabilizes itself against an external load. Biomechanical analysis show that the largest mechanical demands are not isolated to one muscle but distributed across joint moments that change throughout the lift. That means the shoulder, chest and triceps do not work in isolation, they act as a coordinated system solving one mechanical problem. So from the beginning, we abandoned the idea that the bench press is about the chest. It is about force distribution through the upper body. Successful bench pressing is not determined by motivation. It is not determined by sensation. It is determined by three things: joint geometry, force distribution, and coordination. With experience, the nervous system converges on stable solutions. Strength improves by refining that solution, not by chasing feeling. When researchers analyze the bench press, they don't see a simple up and down motion. They see a curved bar path, changing leverage, shifting joint demands, and a direct link between movement strategy and performance. So, what does this tell us? It tells us that strength in the bench press is not just muscle size, and it's not just effort. It is a learned motor solution to a mechanical problem. The nervous system learns how to coordinate joints, how to manage leverage, and how to apply force efficiently under load. That's why the bench press is not just a lift. It is a skillful expression of strength. If this is true, then one question remains. Why is it so often misunderstood? We begin with a hard truth. The most dangerous enemy in any human domain is not the tool. It is ourselves. The gym is no exception. In compound lifts like the bench press, feeling replaces understanding, confidence replaces mechanics. When mechanics are ignored, forces are misdirected. When forces are misdirected, joints absorb what muscles were meant to handle. Technique errors do not appear by accident. They appear by ignorance. This is not opinion. This is pattern. Science is clear. Resistance training has one of the lowest injury rates among physical activities. When injuries occur, they are not caused by the exercise itself. They're associated with poor technique, poor load management, fatigue, or prior injury. Not with the movement itself, which leads to a necessary agreement. Sensation can mislead. Intuition ignores force vectors, technique errors emerge when mechanics are ignored. This phase is diagnostic. We are not asking how do we get stronger. We are asking why does technique break down in the first place? Because our decision-making is fundamentally intuitive. Intuition feels effort. It does not perceive torque. Intuition senses muscle burn. It does not recognize joint loading. Intuition answers only one question: how hard does this feel? It does not tell us which joint is under the greatest stress, how force is distributed between elbow and shoulder, which structure is being protected, which is being overloaded. A bench press can feel smooth, strong, and controlled while quietly placing excessive stress on a joint. The bar does not care what we feel. It only obeys force, leverage, and geometry. And so the search begins. If sensation misleads, if effort is not a reliable guide, then surely there is a correct way to move. A universal technique, a safer bar path, a right answer? There is not. We must begin by dismantling a comforting illusion. There is no single optimal bench press technique. Not across bodies, not across goals, not among elite lifters. Biomechanical research confirms this. Large interindividual differences persist even at similar relative loads. Elite powerlifters do not converge toward one identical technique. They converge toward individual solutions. This alone invalidates the idea of a universal bar path, a universal angle, elbow angle, a universal correct bench press. The bench press is not executed by an abstract body. It is executed by specific anatomy, with a specific goal under specific constraints. So the question changes. Not what is correct, but what effect does this technique have on the joints? Now, we can finally define the problem. Most bench press injuries do not come from load. They come from how force reaches the shoulder. The shoulder's reality. The shoulder is not a deep, stable joint. It is a shallow socket designed for movement, not passive load bearing. Its stability is not built into the bones. It is created moment to moment by coordinated muscle force. When coordination is precise, the joint is centered. When coordination breaks down, the joint is exposed. The shoulder tolerates high compressive force very well. Compression centers the joint, it stabilizes it, but compression only works when force is aligned. Problems begin when load shifts towards shear. Shear slides joint surfaces, stresses passive tissues, and demands constant correction. In the bench press, shear increases when force is no longer transmitted cleanly from the hands through the forearms into the shoulder. The bench press places the shoulder in a mechanically fragile position. The bar does not load the shoulder directly. It loads the hands. From there, force travels through a sequence: hands, wrists, forearms, elbows, shoulder. This is a chain, and chains only work when links are aligned. When the wrists extend extensively or elbows drift out of line, force no longer travels vertically through the system. It begins to drift, it begins to leak, and that leakage does not disappear. It shows up at the shoulder as shear, not compression. The joint is no longer centered, it is being translated. This is not a technique mistake, it's a mechanical consequence. During a barbell bench press, the scapula stops being the primary controller. It is a built-in constraint of the exercise, fixed in place but directing the load. Under these conditions, the system does not simply fail at the shoulder. Instead, it adjusts down the chain. The system shifts demand to the adjustable segments: elbow positioning, wrist orientation, forearm alignment. These are faster, more mobile, and easier to manipulate under load. This is how the kinetic chain compensates. The system protects what is constrained and shifts regulation to what is free. The paradox is this: muscle activation does not change. Joint loading does. A narrower grip, a more externally rotated shoulder, a flatter wrist. These choices alter two things: where load is felt and which joints bear compressive demand. They are not random. The system using distal segments to manage what the constrained scapula cannot. As load increases, bar velocity drops. Acceleration drops, mechanical efficiency drops, while muscle activation rises. That contrast matters because it tells us something important. The lifter is not necessarily failing from weakness, they are failing from coordination stress. as the bar slows, timing becomes more critical, force distribution must be more precise, small errors become magnified. The sticking point, literature shows this clearly. Failure often reflects a joint moment mismatch, not an absence of strength. The muscles are active. The system is producing force, but the force is no longer organized efficiently. The default solution keeps the lift alive. The bar still moves, the set continues, but it also increases the precision required to survive each repetition. And here is the subtle danger. Performance can improve, loads can increase, strength numbers can rise, while tissue tolerance quietly declines. And this is where the system stops helping us and starts costing us. The bench press does not punish immediately. There are reasons for that. Compressive tolerance at the shoulder is high. The joint can handle load, and tissues adapt at least temporarily. Stability is achieved by limiting movement, shortening lever arms, reducing displacement, constraining degrees of freedom. That is why the lift can feel stable for a long time. But pain does not appear when stress first increases. It appears when margin for error has been reduced, after repeated exposure, after compensation has narrowed the buffer. These changes do not unfold over weeks, they unfold over months, sometimes years. Under load, the nervous system prioritizes one thing above all else: reducing threat. Before performance, before power, before expression, it seeks stability. The body does not wait for instruction. It solves the problem immediately. Not intelligently, not optimally, but efficiently. But when compensation becomes the permanent strategy, the system accumulates what it never resolved. The athlete does not feel it until the margin is gone. Before mechanics can be organized, three realities must be understood. Not rules, not preferences. Physical facts the body cannot override. The bench press is not a simple vertical push. It may look vertical, but mechanically it is not. Shoulder reduction and elbow extension cannot occur without horizontal force components. That is not opinion, that is joint geometry. So the idea that all force should be vertical is mechanically incomplete. Biomechanical analysis show that during the press, the barbell is subjected not only to vertical force, but also to significant horizontal and lateral forces. These are not small corrections. They are meaningful components of the total load. In some cases, they reach a substantial percentage of the vertical force itself. So the bar is not just moving up, it's being guided through space forward, backward, and stabilized side to side. And when these forces are ignored, joint loading is misunderstood, muscle activation is misinterpreted, technique becomes oversimplified. We build technique on a force model, and a force model produces force corrections. Reduced range of motion produces reduced adaptation. That principle is not tradition, it is biology. When the bench press is performed through a full range of motion, it produces greater strength gains, higher bar velocity, and more complete neuromuscular adaptation compared to partial range execution alone. It also transfers better across variations, because it trains the movement as a complete motor skill, not a fragment. Long-term training data consistently show greater neuromuscular development, greater strength progression, and more complete motor learning when full range is used as the foundation. Short range of motion benching is not useless. It has a role. Overload work, sticking point emphasis, and rehabilitation contexts, but context matters. Short range is a tool. It is not a base. Full range of motion is the baseline for human adaptation. Not because coaches prefer it, not because tradition says so, but because biological systems adapt to complete tasks, not partial exposure. And when we reduce the task, we reduce the signal. At this point, one question becomes unavoidable. What happens when we remove freedom from the system? Research comparing Smith machine bench pressing to free weights shows something important. Chest activation is largely similar. Front shoulder activation is largely similar, but stabilizing demand is not. And that difference is the entire point. Free weight bench pressing allows a natural curved bar path, a path that emerges from human joint geometry. The Smith machine does not. It forces the bar to move straight even when the joints would naturally guide it along a curve. The lift becomes easier to guide, but it demands less coordination. Constraint changes coordination, coordination changes muscle function. That is the real difference. Free weight bench pressing challenges shoulder stability, demands active force distribution, and reflects how humans actually press. The Smith machine reduces stabilizing demand, simplifies the task, and can be useful in limited contexts. This is not a moral judgment, it is a mechanical one. If the goal is complete upper body development, removing coordination removes part of the adaptation. The Smith machine does not reduce chest activation, it removes the stabilizing challenge that makes the bench press a true human movement. And this pattern extends beyond machines. When we change the exercise, we do not just change muscles. We change which joints are responsible for control. Free weight bench pressing tends to produce lower, steadier shoulder loading with stronger emphasis on elbow extension. Cable crossovers and similar variations produce higher shoulder moments, greater rotational demand, and increased wrist involvement. That does not make cables inferior. It makes them a different problems to solve. And if we do not understand which problem we're assigning to the body, intuition will choose for us, usually poorly. There is no best exercise. There are only appropriate demands. We are no longer guessing. Good technique is any solution that organizes force efficiently while minimizing unnecessary joint stress. Every decision from this point forward has one purpose: organize force, limit accumulation. Not perfection, not tradition, only mechanics. Setup, the load filter. Setup determines how load enters the system. If alignment is established early, force begins in compression. If not, compensation begins under load. And under load, correction is costly. What proper setup restores? Reduces shear at entry, lowers coordination demand, prevents early leakage. Setup does not make the lift easier. It makes the system organized from the start. The foundation of the system. The bench press is performed supine, but the body does not begin at the shoulder. It begins at the floor. Foot contact with the floor creates a closed chain tension that travels upward through the legs, through the hips, into the thorax. It is about system rigidity. A rigid base reduces energy leakage through the trunk. And when the trunk holds the shoulder inherits a stable platform. Without foot contact, the system floats. Setup loses its anchor, bracing loses its base. What this choice restores? Establishes force continuity from the floor up, reduces trunk instability, lowers the coordination cost at the shoulder. The bar is pressed with the arms, but the system starts with the feet. Scapula position, control the constraint. The scapula is constrained between the rib cage and the bench. It cannot move freely, but its position before the lift still determines how load travels. While retracting the shoulder blades matters. Pulling the shoulder blades together does one thing. It narrows the shoulder's degrees of freedom. Less unwanted movement means less misdirected force. The glenohumeral joint stays centered. Force remains compressive, not rotational, not shearing. This does not activate the right muscles, it creates the conditions in which force can travel correctly. Why depressing the shoulder blades matters. Allowing the shoulders to rise changes the geometry at the joint. The humeral head migrates upward, space narrows, passive structures are compressed. Keeping the shoulder blades lowered maintains that geometry. Not to engage a muscle, not to feel stronger, but to preserve the pathway force needs to move through. What this choice restores: limits distal compensation, maintains compressive alignment, reduces joint stress downstream, not to fix a control point. Establish it before load because under load it cannot be rebuilt. Arching. Choose the trade-off. Arching changes mechanics. Less range, shorter moment turns. A flatter press does the opposite. Neither is correct. Each is a trade-off. What this choice restores: adjusts shoulder's demand, changes per rep stress, alters tolerance requirements. Remember, moderate arch, efficient, manageable. Extreme arch, precise, unforgiving. Choose based on control, not ego. Grip width, a joint decision. Grip width is not a muscle choice. It is a joint loading decision. Wider grip, more load potential, more shoulder torque. Narrower grip, less torque, more total work. What this choice restores: changes joint moments, alters stress exposure, defines how the lift fails. Muscles don't decide this, joints do. Elbow and wrist alignment, the gatekeeper. This is where everything is decided. If the chain aligns, force compresses. If it drifts, force shears. What this choice restores: preserves vertical force transfer, minimizes anterior shear, directly protects the shoulder. Nothing compensates for this. This is the gatekeeper. Bracing protects the system. As load rises, precision matters more than strength. If the trunk loses rigidity, force leaks, segments drift, stress rises. What this choice restores: maintains system integrity, reduces coordination cost, stabilizes force transfer. Bracing does not add force, it prevents loss. Execution remove variability. The bench press is not just down and up. It consists of 4 mechanical phases: descent, transition, initial drive, and lockout. Only part of that sequence represents productive work. The rest requires control. As load rises, mechanical efficiency drops, precision requirements rise. The small errors become magnified. Sloppy execution does not just look bad, it amplifies stacked stress. Because every controlled transition adds variability to the joint loading. The variability under fatigue narrows margin. What controlled execution restores? Predictable mechanics, reduced joint loading variance, higher repeatability across sets. Control does not make the lift slower, it makes the lift consistent, and consistency protects tissue tolerance. The bench press becomes safer not by reducing load, but by organizing it. Every choice must answer. Does this improve distribution or reduce accumulation? If yes, keep it. If not, remove it. The bar does not injure us. Mismanaged force does. And mismanaged force always leaves a trace. After everything we've examined, one thing should now be clear. The bench press is not a chest exercise. It is not a shoulder test, and it is not dangerous by default. It is a load-bearing coordination problem governed by physics expressed through biology. When understood, the lift is not just safe, it can be protective over time. The bench press is a system-level task. When we press a barbell, the body does not think in muscles. It organizes joints, segments, force pathways, and timing. Strength does not come from feeling a muscle. It emerges when structure, coordination, and exposure align. Technique is force management. Every technical choice exists for one reason: to manage force. Grip width, elbow angle, range of motion, tempo. These are not rules, they are tools. They decide where stress goes. When technique respects mechanics, the lift becomes efficient, repeatable, and durable. Durability is not luck, it is engineered. Load is not the enemy, disorganized load is. Strength comes from exposure. The body does not become resilient by avoiding stress. It becomes resilient by organizing it. The bench press is not the only tool, but it is the foundation. Heavy load is a teacher. Heavy load does not create danger. It reveals structure. It slows the system. It exposes alignment. It magnifies error. Not to punish, but to clarify. When mechanics are sound, heavy loading is not reckless. It is precise. The bar is honest. It shows what is organized and what is not. The bench press as a teacher. More than almost any upper body lift, the bench press teaches discipline. Setup before action, tension before movement, control under load. It does not reward chaos, it does not hide error. It exposes compensation and rewards structure. The bench press is not sacred, but it is not expendable. It is a fundamental free weight task that reveals how well we can organize force under constraint. When understood, it builds strength, resilience, and coordination that carry everywhere else. When misunderstood, it becomes inefficient, painful, and unnecessarily complicated. The bench press is a biological problem solved by physics. The bar never lies. Only our understanding does.